last video, we introduced dimensional analysis and we talked about how to turn conversion factors into their fraction forms. In this video, we'll go over how to do dimensional analysis. Now I'm going to go through a quick overview, but I promise we're going to slow down in a minute. First thing you're going to do is make a grid, just like this one. Then you're going to put the number and units you are starting with, the ones you want to convert, in the upper left section of the grid. Now the bottom section is usually going to be left blank. If you want to put a smiley face down there, you can. I saw it on the internet once and I thought it was cute, so sometimes I do. It's not really scientific, but go for it if that's what you want to do. In the next column, you're going to put the conversion factor in fraction form, but you have to put it in the right direction. You want to flip it so that the units you want to convert to are on the top, and the units you want to convert from, the ones you don't want, are on the bottom. Now, you are going to cancel out any units that you see on both the top and on the bottom. In other words, units that are above the horizontal line that are also below the horizontal line. Then you're going to multiply everything remaining on the top and divide by everything remaining on the bottom. And you keep any units that have not been crossed out. And there may be units on the top and on the bottom. Simplify anything that needs to be simplified and rewrite your final answer. And if you want to make your teacher really happy, you will circle your final answer or put it in a box. Let's go through some examples. So we are asked to convert 34.5 millimeters to meters, and we're given the conversion factor 1 meter equals 1,000 millimeters. Now the first thing we're going to do is put the measurement we want to convert from in the upper left-hand part of this grid. That's going to be 34.5 millimeters. It's very important to write the units down here. Don't forget them. I'm going to put a smiley face down here just because I think it's cute. And then the next thing we need to do is to take our conversion factor and convert it into a fraction that we can use to help cancel out our units. Now, there are two possible fractions we can get from this conversion factor. We have 1 meter divided by 1,000 millimeters. We could also have 1,000 millimeters divided by 1 meter. We're going to put one of these fractions in that second column. But we need to do this so that the units we are converting to are on the top and the units we are converting from are on the bottom. So if we take a look at this, the 1 meter is going to be on the top and we want to convert from millimeters. So we're going to put that on the bottom. Now we can see that we have millimeters above the line and we also have millimeters below the line, and we can cancel these out. And the only measurement we're left with is meters, and that's what we want. So now we take everything at the top of the line and we multiply that all out, and we're going to do the same thing on the bottom. So we now have 34.5 meters on the top and 1,000 on the bottom. And this is a fraction. We're going to simplify this, and when we do, we have 0.0345 meters. And that is our answer. There's another way you can do this too if you don't want to use a grid. It looks something like this. And it's what we do a lot of the time in algebra and algebra 2. And if you're comfortable working the problem this way, feel free to do that. But many people like to use the grid when they're first starting out. Let's do another one. We're asked to convert 261 grams to kilograms, and we're given the conversion factor 1 kilogram equals 1,000 grams. Try this one on your own, and then we'll work through the answer together. The first thing we're going to do is to put the measurement we want to convert from in the upper left-hand part of the grid. I'm going to put a smiley face down at the bottom just because I can and because I think it's cute. Now I'm going to take my conversion factor and I'm going to make the fraction forms of it. I've got 1 kilogram over 1,000 grams. I could also have 1,000 grams over 1 kilogram. I'm going to put one of these into the second column, but I've got to figure out which way to orient it because I want to get rid of grams, but I want to convert to kilograms. So kilograms must go on the top. So I'm going to put it in this way, 1 kilogram on the top and 1,000 grams on the bottom. I can now cross out grams because it's above the line and below the line. We're going to multiply everything on the top, and that's going to give us 261 kilograms because kilograms are the only units that are left. And I'm going to do the same thing on the bottom. That gives us 1,000 because we've crossed out our grams. And I can go ahead and simplify this because it is a fraction. And I will get 0.261 kilograms. And if I want to make my teacher happy, I will circle this. Now, if you're comfortable, you could always do this as one big long equation. But I want you to do the way that makes the most sense to you. Now, this last example is going to be a challenge question. Sometimes you need to go through more than one step to convert something. In this example, we've been asked to convert 4.5 hours to seconds. Now, we haven't been given an hours to seconds conversion factor. We've been given 60 seconds equals 1 minute, and we've been given 60 minutes equals 1 hour. Now pause the video. See if you can figure out a strategy that we could use to do this. There are 2 ways we could work this through. One way would be to do it as 2 separate conversions. For example, we could first convert from hours to minutes, and then we could convert that answer from minutes to seconds. But often in chemistry, it's more convenient to do this as one big long problem. I'll show you what I mean. I'm going to make the same scaffold, but I'm making it a little bit longer. I'm adding one more column because we have an extra conversion to do. Just like before, I am going to put what I want to convert from, the 4.5 hours, up in the left-hand corner. And you know me, I'm just going to throw a smiley face in the bottom as a placeholder. Now I've got to come up with a strategy. I start with hours. Let's convert from hours to minutes first. I'm going to find a conversion factor, nice little ratio here, and I'm going to put it in so that 60 minutes is on the top and 1 hour is on the bottom. Well, I know I can cross out hours, and that's going to leave me with minutes. I'm not going to multiply out just yet. My next step is I need to get from minutes to seconds. So I look at my other conversion factor, and I see that if I made a fraction with 60 seconds on the top and 1 minute on the bottom, I could put it in this next column, and you see I can cancel out minutes. So let's look at everything on the top. We got a bunch of numbers I can multiply together, and we also have the unit seconds, and that's what I want. So let's do that. We'll multiply all the numbers, and then we'll put seconds as our unit. We're going to do the same thing on the bottom, but notice that on the bottom we just have numbers, and 1 times 1 is 1. So we'll pop that in, and when we simplify, we have 16,200 seconds. You can also do this the big long equation way, but you don't have to. Now, if anybody's curious as to why we could do this in the first place, it's because when we make our fractions out of the conversion factors, they're equal to 1. And we can prove this using algebraic substitution. For example, take a look at this conversion factor. 1 meter equals 100 centimeters. Well, we can put this into a fraction with 1 meter on the top and 100 centimeters on the bottom. Now, if you remember substitution from math class, because 100 centimeters is the same thing as a meter, we can switch out. We can put 100 centimeters on the top instead of a meter. We can just exchange them. And I hope you will notice that 100 centimeters over 100 centimeters can be simplified to 1. So what we're basically doing here is we are multiplying the thing that we want to convert by 1. So this is how we just did it in the equation. The numbers and the units have changed, however, the actual length has not changed. So let's go back to that cat again. The actual length of my cat is 18 inches. If I did dimensional analysis, I'd find that this little guy is 46 centimeters. Now, his length is still the same. It's just that we've basically translated it from one language into another language. So in summary, dimensional analysis is a technique we use in science class to convert from one type of unit to another. A conversion factor is what we use to relate different units to each other. For example, 1 inch equals 2.54 centimeters. We can make fractions out of our conversion factors, and we can use these fractions through multiplication to convert from one type of unit to another.